When he was a teenager, computer engineer Luther Palmer wanted to build the Terminator. And while this robot might look more like a big roach than Arnold Schwarzenegger, its unique leg system is designed for rough running.
What we are asking robots to do now, terrestrial robots, is really just the tip of the iceberg of what we will want robots to do in the future. So one of the ways to extend the capabilities of robots is by adding more complex legs and making those legs operate more smartly. What has been a nemesis for these systems in the past has been kind of uneven terrain or unexpected terrain, loose terrain. Stuck, I think.
With support from the National Science Foundation, Palmer and his team at the University of South Florida are designing simulation models for the next generation of robotic legs, then building them in the lab.
And in the past, legs have been built kind of with the glorified pogo stick where there's just a linear spring. But if we put a knee and an ankle joint on the leg, right, what should the springs at the knee and the ankle look like?
Palmer looks to the biomechanics of animals adept at running on rough ground to program the computer algorithms that power the simulations.
So we do a fair amount of gathering information from biological sources about how horses run, one of the more well-studied animals, and how humans run, pulling some data from motion capture systems, and that gives us kind of a framework to form the algorithm.
A big challenge is designing robotic legs that move effectively and efficiently without sucking up too much computer processing power. After all, we usually move around without thinking about every step we take. Why shouldn't a robot?
We know that kind of humans and animals kind of have two modes of walking or running. One is the kind of a top-heavy brain is telling the legs what to do, when to do it. But when running fast or moving quickly, there really isn't enough time for a lot of information exchange. So that's what we try to model with our hexapod walker.
Palmer sees broad applications for these smart legs. Military robots that can walk alongside soldiers to carry heavy loads, spacefaring robots that run like horses over the surface of Mars, and search and rescue robots that can move through a debris field looking for survivors.
So a mobile robot that has legs, that can run and jump and even climb walls would be a valuable asset in some of these situations where time is of the essence.
The old saying goes, you have to crawl before you can walk. So think of these little guys as giving a leg up to running robots to come. For Science Nation, I'm Miles O'Brien.